All right, so we're looking at these two function rules up here. And what we're asked to do first is we're asked to find f of 7. How do we do f of 7? How do we do this? Substitute 7 in for x. Absolutely right. So I'm going to take my f function. It's this minus 4. And we're going to substitute this 7 in place of the x. Plus 3. And so we're going to simplify this. Negative 4 times 7 gives us negative 28 plus 3. So what does this equal? Negative 25. So this is our answer for f of 7. It's a substitution thing. Same thing with the rest of these. All of these are substitution problems. So the next one says g of negative 8. That just means we use the g rule. And we're going to take our 1/2 times negative 8 minus 3. And what are we going to get?
Negative 7.
Yes. I had to think it through. Negative 7, because negative 8 times 1/2 is negative 4. Negative 4 minus 3 is negative 7. Same thing for f of 1/2. We're going to take our negative 4 times 1/2 plus 3. And what are we going to get as an answer? 1.
The teachers at this time, all sophomores go to the auditorium with sophomore teachers. Again, sophomores to the auditorium at this time.
We only have like 6 of y'all, so have fun.
Directly from the auditorium.
Take your stuff.
Again, sophomores and sophomore teachers move to the auditorium.
I will get the video posted. I should by the end of 4th, so in 5th you'll be able to watch and catch up on stuff. We're also going to use it over the next several days, so you'll be all right. Have fun. Enjoy your meeting. Time for the meeting. That is an old commercial I haven't thought about in years. Oh my gosh. That was a reference that none of y'all will catch. Oh my gosh. I'll have to tell my friend, because she'll catch it. All right. We only have 2 more of these. So we're going to have our 1/2, and our x is negative 1/2 minus 3. This one's a little bit harder. Because 1/2 times negative 1/2, when we multiply fractions, we multiply across. So we end up with negative 1/4 minus 3. So it's really negative 3 1/4, or 3.25. So the fraction stuff gets weird and kind of annoying, but it is what it is. And I feel like my screen is really dark. There we go. That does feel a little better. Somebody's playing with buttons on my screen and I don't like it. Yeah, that feels more like where it's supposed to be. All right, and then our last one, we have 2 of them and there's an operation in between, and that's okay. So we're gonna do f of 6. F of 6, that's negative 4 times 6 plus 3. Negative 4 times 6 is negative 24. Plus 3 is negative 21. Now there's this minus in between. And we're going to do g of negative 4. 1/2 times -4 is -2. -2 minus 3 is -5. So we've done all the operations. I just did them out loud instead of writing them down because I don't have enough space. And we wind up with -21 minus -5. And what's the answer for that? What is -21 minus -5?
-26.
Not quite. What happens with the double negative? It turns positive. So it's -21 plus 5. So it's actually -16. Okay. So what we're going to be doing today is actually going to start with using this kind of stuff. So we're going to start with, it's called composing functions, and I'm going to put up like as a wall of text, and you don't need to write the whole thing down. What I want you to write down, child, is I want you to write down these things at the bottom. These are different notations, and I'm actually going to change a thing on here. So I'm going to change the size of this piece. It's not going to be different. I'm just changing how it's sized. There. I'm changing this one too. So what we're going to be doing is very much like we did in the bell work problem where we would substitute a number in, but now we're going to substitute in whole equations. And it's very much like when we would do substitution in our systems of equations that we did last semester, when we would take like the y equals and substitute that in. It's the very same vibe. It's just got a weird notation here, and I'm going to switch back and forth and use all 4 of the ways that it's written up here. But what these are and how we read these is this says f of g of x. So what this means is we're going to take our g of x function and put it in place of the x. We're going to substitute it in our f of x. And the bottom one is g of f of x. So we're kind of having one function eat the other one. You're just going nom nom nom, and it's going to go inside the other one. And we'll work with it. We're going to start with doing it with numbers first, and then we'll go into doing whole equations. The paragraph thing at the top is from the textbook. If you like the formal definitions, you're welcome to it. But these bottom pieces are really the pieces you need, is this notation. We're taking g of x and putting it inside f. We're taking f of x and putting it inside g, or we can get all kinds of crazy and put whatever things inside of whatever other things. But what we're going to start with is we're actually going to start with a couple of list of points, and we're going to start with doing this with numbers and just seeing how they eat each other as we go through. Okay? So, are you ready? I've got 2 function rules here, and they're just list of points. They're not equations. I've just got the f of x is 1, 2, 10, 11, 0, 3, and 9, 7. Like, it's just straight up a list of points. Same thing with g of x. And what we're asked to find here is f of g of 4. And I am going to do so much color coding today. Like, it's not even easy. Yes, ma'am. Boop. Yep. So what I want us to do is we're going to do it, it's kind of starting from the inside and working our way out. So we're going to first do g of 4. So we're going to look at g. We're going to say, all right, g, if x is 4, what's y? So let's look at G. Find when f is 4. So we look at G over here. It's this bottom one. We're going to find when x is 4. That's this first point right here. So we're looking at this guy. If x is 4, what's y? 1. So G of 4 equals 1. Right? What's f of 1? So look up in our f. Find when x is 1. When x is 1, what's y? 2. So f of G of 4 is 2. It's kind of following a trail. We went from 4 to 1 and from 1 to 2. That is horrible to read. Oh my God, there we go. We're going to do that a couple more times to practice through this. So we're going to do f of G of 5. So first thing we need to figure out is what is G of 5? So we're going to look in G. We're going to figure out when x is 5, and we're going to find that point. G is 5 right there. So what's y? 0. So then we're looking for what is f of 0? Is 3. We look for when x is 3 or x is 0. That's not a highlighter. That's the wrong color. There we go. So f of 0 is 3. Okay. I can do that. I'll do it this time without doing the highlighter path. So our next one is f of G of 13. What is G of 13? 9. So then we have f of 9. What's f of 9? 7. Yeah. So we're following the trail. 13 to 9, 9 to 7. And we can go in whatever direction it says. Sometimes they'll get like really, really long. They'll put like 5 or 6 points in a row. Our last one is G of f of 1. So we're going to do G of f of 1. What is f of 1? 2. I heard it. It was quiet, but it was there. What's G of 2? None. It doesn't have one. So what we say is that it is undefined. It doesn't have a definition. It doesn't tell us what 2 means in G. We can only go off what we got. It's not a line, it's just a list of points, and there is no 2. So it's undefined. So when we have a list, this is called a finite list of points, we can just kind of substitute and follow the line, follow the numbers. So with points, it's not too terrible, but what's going to happen when we have equations? I wonder what we're doing next. Oh, snap. Okay, so if we have numbers, it's substituting them in. We figure out what x is, and we substitute it in. So then what we're going to do is we're going to take two function rules here. So we're going to use equations. We're going to have f of x equals 2x minus 5. And we have that g of x equals 3x. And what we're going to do is exactly the same thing. We say, all right, it says FOG down here. So that means we want F of G of X. So we're not putting in a number. We're just going to leave the letter in there. And what I'm going to do is I'm actually going to write out my equation here. But instead of an x, what we're going to do is we are substituting this in place of the x. So it's going to be 2 times my g of x. Oh my gosh. Minus 5. So we're taking that g of x and substituting it in place. So we're going to have 2 times, and I'm going to put my function rule for g of x in. 3x minus 5. So you see how f of x has looked at g of x and gone, nom, 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 boop, now you're inside. And it ate it. We're putting that 3x in place of this x here. And the 3x went right in that little spot. Took its home. Then what we're going to do is we're going to simplify it. So f of g of x, we're going to simplify. We have 2 times 3x, and that's going to give us 6x minus 5. So f of g of x is 6x minus 5. And that's our answer on that. And I know it's the first time we've gone through it, so we may not even know what our questions are yet. But questions on this first one. Okay. It's good to see that we don't even know how to word our questions yet, and that's okay. So let's do another one. It's going to go the other direction. It's g of f of x. That's what that circle means. So we're going to have our g of f of x. That means g is going to eat f of x. Nom, get in my belly. So what that means is I'm going to take my g of x function, my 3 times something, but it's really 3 times f of x. Well, that's all well and good, but it'd be a whole lot easier if I could actually see my equation. So we're going to do 3 times 2x minus 5. And we're substituting the pieces in. Now, what can I do to simplify that? Distribute. So we get 3 times 2x, giving us 6x, and 3 times minus 5, giving us minus 15. So g of f of x is 6x minus 15. Okay. Questions on those two? Okay. Sometimes they go a little crazy with what they ask us for. Because now they're going to ask us for f of x. So I'm going to rewrite it with our little parentheses because it makes it way clearer. So we're going to take our f of x and we're going to substitute in f of x again. These kinds of questions show up on things like the SAT all the time. They love to do a composition with itself. Okay, so these kinds of ones show up on SAT a lot. Because I know they're weird and like super overcomplicated. Like, oh man. But what we're going to do, it's exactly what we did before. I'm going to start with taking my equation from up here. My 2 times something, but all I know is in place of this x, I'm supposed to put f of x minus 5. When I do that, when I have 2 times 2x minus 5. Minus 5. So I'm substituting it in, and this is one time when I think my color coding tendencies really help to clarify stuff. So if you ever want to use colors or need colors, I have a gazillion highlighters, color, and pencils and stuff. Markers, crayons, whatever you need. I got them all. Okay, so then all we need to do is simplify this. So I'm going to distribute this 2. So we have 2 times 2x giving us 4x. 2 times minus 5 giving us minus 10. And then that minus 5 is dropping down. So f of x equals 4x minus 15. So we keep ending up with equations that are really, really close to each other. They're very, very similar because they're all built from the same pieces. It's like taking 6 Legos and making 4 different shapes. So it doesn't matter what we call it. I'm just making it eat other things. And our last one with this set of equation is we're going to do the same thing but with the g's. So I'm going to take g of x. So I'm going to put g of x inside of itself. So we're going to take our 3 times g of x. The most common mistake I see on these is when we substitute this in, we leave an x here as well. Do not leave other letters. We're putting this g of x in place of the x. So this is really 3 times 3x. So g of x is just 9x. The most common mistake I'll see on this is that somebody puts 9x squared. Because it's taking the things we did yesterday and turning this into a multiplication instead of a composition. So we're not just trying to make them multiply. One's got to eat the other one. Nom nom. Questions on our compositions? Because we're going to do another set. Because it's all well and good when we have linear equations, but sometimes we get a little wild, a little cray. And we give you an x squared. Okay, so we're going to do another set of these, and I've got new function rules for you. So we have a new f of x and a new g of x. So my new f of x is x squared plus 2, and my new g of x is 2x. Oh, love that. There we go. All right. So we're still going to treat it exactly the same way. We're going to take our f of x and our g of x, and we're going to make them substitute into each other. So here we have f of g of x. So we're going to take our f of x, but in place of the x is where we substitute in g of x squared plus 2. So that's going to give us, g of x is actually 2x squared plus 2. Any place I have an x is where I substitute that in. So then what we're going to do is we need to simplify this. What is 2x squared? How do we simplify that? Huh? It's going to be 4 because it's 2x times 2x. So we have 4x squared plus 2. Can I simplify that any further? So that's our answer. 4x squared plus 2. So it works just the same way if we have more complicated polynomials. So let's do g of f of x and go the other direction over here. I'm substituting f of x in place of the x. So we're going to have our 2 times f of x. Also known as 2 times x squared plus 2. So we've substituted that whole equation. This whole equation got put in place of this x. 2 times x squared plus 2. And if this step does not help you and you can jump straight to here, I'm okay with that. You guys can never have to write as many steps as I do. I just try and figure out all the places where our brains get stuck. So on this last one, all we need to do is we need to distribute here. To simplify this out, 2 times x squared gives me 2x squared, and 2 times 2 gives me plus 4. So on this one, it's g of f of x equals 2x squared plus 4. And again, this notation, they mean the exact same thing. I find this one way easier to evaluate when it's in the parentheses form because it looks like I'm substituting in it. So I like to work with it this way. It will more often than not be typed this way just because otherwise it gets really confusing because of the sheer number of parentheses. So it tends to be written this way in instructions, but I find this way to be way easier to work with. But if you can work it from here, great, more power to you. Totally fine. Okay? One more question that I want to do. Last one. And it's a story problem, and I'm sorry I did not actually print it out for you. But there's a story problem very, very much like this on the homework. So I want to make sure we do one. So this says a movie theater charges $8.50 for each of the tickets sold. And the manager wants to determine how much money that theater gets to keep. They have to give the studio 75% of the money earned on ticket sales. So we want to figure out how much they get to keep out of each ticket. What can we do to set this up? There's a few different ways to go. I know it's $8.50 for every ticket. If X is our number of tickets, because that's what they said up here. And they have to give the studio 75%. I'm going to put this as maybe an equals Y. Y is the money made from sales. So if they need to send the studio 75% of the money made, how could I write that as an equation? What percent do they get to keep? If they have to send 75% away, what percent do they keep? 25%. How do I write 25% as a decimal? 0.25 of the money that they sold. So it's 0.25 of whatever Y is, right? Is the movie theater's money. I'm just going to put a dollar sign. So the reason they're having this in our composition section is they're expecting us to figure out these equations, take this guy in, and compose it in here. It's a system of equations kind of deal. So what we're doing is we're taking our 0.25 times our 8.50x. So when we're figuring out how much money from each ticket, we're going to multiply 850 times 0.25. So what is 0.25 times 8.5? This is the last thing. Type in the calculator and then we're done. 0.25 times 8.5. Two point what?
125.
125. I'm going to round it up to 13. So for every $8 ticket that they sell at the movie theater itself only gets to keep $2.13. And honestly, I think that's a little bit high. I think they really have to actually give like 85%, 90% of the money from ticket sales to the brokers. Movie theaters only make their money off of like the snacks and stuff. My brother-in-law works in a movie theater, so that's why I know that. Okay, so it's really asking us, it feels a lot more like a system of equations than a composition because they're really the same process, just with different labels. Okay, so the story problem If it helps you to come at it from a different direction, come at it from a different direction. Totally fine. It does not have to be a composition of functions. Whatever path your brain goes to get there, take that path. I am cool with that. Okay? So that is everything we need to get through today. You guys have 8 minutes. So you can work on stuff on that homework. It's the same homework from yesterday, that same worksheet. We did everything on the back now. So you guys are good to go. Just be careful when we're substituting stuff in. Okay? Have a great rest of your day. Have very lovely class meetings. Most of you guys are going to go next period. No saying.